Hi guys, welcome to the Power DSP lessons. In the last two lessons, we have seen what is the concept of convolution with an example. In this part, we are going to see the convolution equation. In fact, we are going to derive the equation from the concept of convolution. Okay, let's get started. In convolution, we are decomposing the signal and taking only one sample at a time. Then each sample is expressed in terms of shifted and scaled version of an unit impulse. The output for each sample is calculated by applying the linear system properties. Finally, the output is calculated by applying the superposition principle. Let's take a infinite length signal x of n with 3 samples for example, which are at the sample indexes n is equal to -1, 0 and 1. The sample at n is equal to -1 is expressed in terms of shifted and scaled unit impulse. The same amount of shifting and scaling is appeared at the output. Similarly, the samples at time index n is equal to 0 and n is equal to 1 are expressed in terms of shifted and scaled version of the impulse. The outputs are then derived. If we add all these samples, we get the input signal x of n. We can generalize this by the equation x of n equal to sigma x of k into del n minus k. So, any signal can be expressed by the sum of scaled and shifted impulses. By superposition, we know that the sum of the response of the system to each of the individual input signal is equal to the response of the system to the sum of the decomposed signal. So, the response of the system is equal to the addition of all these outputs. We can generalize the equation by introducing the variable k for the sample index values. The convolution equation then becomes y of n equal to sigma n equal to minus infinity to plus infinity x of k into h of n minus k. This equation takes the limits from minus infinity to plus infinity because x of n is considered as an infinite length signal. Practically speaking, we always want to process the finite length signals. So let's take a finite length signal and calculate the number of output samples. Here x of n is of length n and length of h of n is m. Let's find the number of output samples now. The output for the input sample at index n is equal to 0 is just the scaled version of the impulse response. And there is no shift because the sample is at the time index n is equal to 0, which is same as unit impulse. The output for the input sample at index n is equal to 1 is both scaled and shifted version of impulse response. The amount of shift is equal to the input sample's shift from the origin, which is equal to the time index n. In this case, it is 1. Similarly, the amount of scaling is equal to the input sample's amplitude. In this case, it is 1. Similarly, the output for the input sample x of n minus 1 is shifted by n minus 1. First sample of scaled h of n is placed at the time index n, and the remaining m minus 1 samples of scaled h of n are placed thereafter. The output of the system is calculated by adding the same indexed values in all these outputs. This contains the maximum samples and so the final output. So the final output contains n plus m minus 1 samples. This is the finite length convolution equation. Y of n is equal to sigma n is equal to 0 to n minus 1 x of k into h of n minus k. The summation runs from 0 to n minus 1, which is equal to the number of samples in x of n. Okay guys, we have seen the convolution equation for infinite and finite length signals, and we have also calculated the number of output samples for finite length input signal. That's all for today's lesson. Bye bye.